Hey y'all. Today's objective is rotations. We've been working with transformations. So quick review, a transformation is when you change a figure, an operation to change a figure. And the main transformations we are looking at, sorry, I'm checking my volume. We've looked at reflection and translation. And so today we're going to go over rotation, which is a turn. And then the last one that we're going to look at is a dilation. So a rotation is a turn. You rotate it around the origin. The image, which is the figure after you have rotated it, is still congruent. So we are not changing the size or the shape of the figure. It's going to be a congruent figure. And you can either rotate it clockwise or counterclockwise. Clockwise means the way the clock goes, or counterclockwise means opposite of the direction of a clock. So let's go over some examples about rotations. All right, example 1. Copy this down, and I expect you to copy this chart down, and when I tell you to rotate your paper, actually rotate it. Rotate this quadrilateral FGHJ 90 degrees clockwise. So 90 degrees clockwise is the way a clock rotates. So first we're going to graph our pre-image. We're going to graph our original. So F, 2, 2, G, 2, 4, H is 4, 4, and J, 5, up 2. All right, so F, G, H, J. There is our original figure. You do that on yours, and now we're going to rotate it 90 degrees clockwise. So I want you to actually rotate your paper. I'm going to rotate the board. 90 degrees clockwise means one turn, 90 degrees, and we're going to go the direction. So you're going to actually take your paper and turn it 90 degrees clockwise. So now you see that our quadrilateral is pointing down. The way you can do a rotation and actually graph it is physically rotate your paper, and then we take the coordinates where they are now. And what I mean by that is now this is our x. See where it says y because originally it was vertical. This is our x and this is our y. So we can get our new coordinates. So watch me. F prime is still where F is, except now it's the translated. So now it is over 2 and down 2. So now we're going to kind of treat this as like the x-axis and this is the y-axis. So we're going right 2 and then down 2. So 2, negative 2. G prime is 1, 2, 3, 4, right 4, and then down 2. H prime is right 4 and down 4. And then J prime, we went right 2 and then down 5. So that is how you get the new coordinates of a rotated figure. We actually rotated our paper 90 degrees, and then we keep the shape exactly where it is, and that is what a rotated 90 degrees clockwise would look like, because my paper was originally like this, and then I turned it clockwise, so the way a clock goes, and then I just did it one turn. And so there are my new coordinates. So I'm going to write them over here. 2, negative 2, whoops, F prime. G prime is 4, negative 2. H prime is 4, negative 4. And J prime is 2, negative 5. So before we go to the next example, I just want you to look and see, do you notice any kind of anything special with our coordinates? As far as the numbers, positive or negative, so just take a look at that. And again, a rotation keeps the shape congruent. So the shape is the same size, and all the distances are the same. The only thing that's changing are the coordinates. So let's do another example. All right, copy this down, coordinate plane and everything. All right, we need to graph this pre-image, this original image, this pre-image. Negative 6, 0. Oh, so it's right here. So it's A. negative 5, 2, up 2, and then negative 1, 3. Negative 1, 1, 2, 3. So we have a triangle. Ooh. And that is our pre-image. That's our original image. We are going to rotate it. It says rotate triangle ABC 180 degrees. 180 degrees doesn't need a clockwise or counterclockwise because 180 degrees would be the same. It's like 290, so you're going to go 1, 2, or 1, 2, and you're going to end up in the same spot. 180 degrees means you turn your paper 2 times. It doesn't matter the direction, so I want you to actually turn your paper 2 times. It's going to go upside down. So that would be 90 degrees, and then this would be 180. And again, you are going to keep the shape where it is, and just imagine this is your X, and this is your Y, and now these are positive and these are negative. So I'm going to get my points. A prime is 1, 2, 3, 4, 5, 6, 0. B prime is 1, 2, 3, 4, 5, negative 2, because now we're going down 2. And C prime is 1, negative 3, because we went over 1 and down 3. Those are my new coordinates for the image. Now, if I wanted to graph them, I could. And I would graph A would be 1, 2, 3, 4, 5, 6, 0. So that would be A prime. B prime would be 5, negative 2. And C prime would be 1, negative 3. And then I could graph, whoops. And you can see I've graphed my rotation, but you don't actually have to graph it to get the vertices. You just need to rotate your paper and write them down. So my new vertices are 6, 0, B prime, 5, negative 2, and C prime, 1, negative 3. So look and compare the pre-image to the image at these coordinates, and maybe you notice something, and I'm about to show you maybe what you're noticing on the next slide. Key concepts. You want to write all of this down for rotations. Here are the key concepts for rotations. If it's a 90 degrees clockwise, that means just one rotation clockwise, it's also a 270 degrees counterclockwise. 270 would be 3 90s. 90, 180, 270. So these actually are the same place if you rotate. Here is transformation notation, algebraic notation. If you have a point A, which is x, y, those are the coordinates, and then you rotate it, it goes onto A prime, y, negative x. And what that means is you switch the coordinates. Notice x, y, I've switched them, and I've multiplied the new y, not y, but the new y by negative 1. Notice x is now negative x. So if you rotate it 90 degrees clockwise, you switch the coordinates and you multiply the new y by negative 1. So in this example, A is 2, negative 3. If we wanted to rotate it 90 degrees clockwise, we would switch them, negative 3, 2, and I would multiply the new y by negative 1. So I would make that a negative 2. So that would be the coordinate of a 90-degree rotation. For 180 degrees, remember, it doesn't matter if it's clockwise or counterclockwise. You have a point A, which is the coordinate x, y, and it goes to negative x, negative y. What that means is you multiply both by negative 1. You do not switch the coordinates for 180 degrees rotation. You just multiply them both by negative 1, or you find the opposite. So for an example, if you had the point A for negative 1, we wanted to rotate it by 180 degrees, we would multiply them both by negative 1. So 4 times negative 1 is 4. Negative 1 times negative 1 is 1. And that would be your new coordinate. For 270 clockwise is also the same as 90 degrees counterclockwise. So what I've shown you is 90 degrees clockwise, 180 to 70 degrees clockwise. Or you could work backwards. 90 degrees counter, 180, 270 degrees counter. If you have a point A, which is the coordinate xy, and you goes to, if you are rotating it 3 times, 270 degrees, 1, 2, 3, you're going to switch the coordinates again. Notice I've switched my coordinates, but this time I've multiplied the new x by -1. So see, it doesn't mean you multiply, the new y. It's the new x value, which would be the y coordinate. So it's the new x value by -1. Here's an example. If we have a point 5, 3, and we want to rotate it 270 clockwise, we switch the coordinates, 3, 5, and we multiply the new x by -1, so that would be -3. Do I expect you to remember all these? Eventually, I think you'll get the hang of it, but if you can visualize where rotation is going to go, it's going to help you remember, all right, I switched them, I don't. I multiply the new x, I multiply the new y. But I'm going to show you, keep this handy so you can see it, and let's go over our last few examples. Copy all this down, pause it, copy all this down. Without graphing, find the coordinates of the vertices of the image after the rotation. So I've given you 3, and this last one's a U-try. So 90 degrees counterclockwise. If you were doing counterclockwise graphing, you would turn your paper that way. But I'm going to use my chart that I just made, and I'm looking up 90 degrees counterclockwise. 90 degrees counterclockwise is also 270 clockwise. And I'm looking at my chart, and it says, I'm reading it right here, it says XY transforms to 270 clockwise, -yx. You switch them, and you multiply the new x by -1. You switch them, and you multiply the new x by -1. So that's what I'm going to do. I'm going to switch them. Well, this one is still the same. And the new x by -1. B prime, I'm going to switch them. And the new x by -1. C, C prime, I'm going to switch them. And the new x by -1. And then D prime, -4, 1. All right. So if you have your chart, that is going to be your new best friend for a few days, helping you remember what you do with your coordinates for a 90 clockwise and 90 counterclockwise. If the rotation is 180, you do not switch. You just multiply them both by -1. K prime, -1, -1. I'm going to multiply both coordinates by -1, and I'm not switching. L prime, -3, -1. M prime, -2, -3. And N prime, -1, -3. That one seems simple enough. If it's 180 degrees rotation, you do not switch them. You just multiply them both by -1. All right, you try 270 degrees clockwise. Look at your chart and just follow the algebraic notation on your chart and pause it and press play when you're ready. So I'm looking at my chart. 270 clockwise means XY changes to -yx. Did I just do this one? Oh yeah, 90 degrees clockwise is the same as 270 counter. 90 degrees counter is the same as 270 clockwise, so it's going to be the same pattern. Our new x coordinate is going to be negative, and I'm going to switch them. So L prime, -1, 3, M prime, -3, 2, and N prime, -3, 1. Sorry, I have my back to you. I was trying to write. Double check yours. I switched all of the coordinates, and then I made my new x value negative, and that is what you should have gotten for a 270 degrees clockwise rotation. Make sure you have your notes, and you can read them, and we will go over this in class.